Starting with the first one, what do I need to do? Yeah, don't even look at the 4 for a few minutes, and then do what? Put the t on the bottom. So we're going to go with LNT. When I get to the trig functions, I'm probably going to change all the letters to X because it looks a little bit easier when I do that. So if I change the variables, I'm sorry, just deal with it, I guess. I don't know. All right. What do I do now? What's the derivative of LNT? Derivative of t to the -2. -2t to the -3rd. We don't divide fractions. Remember, this is a fraction. It's going to be -2 over t cubed. So this is -2 over t cubed. So we're going to flip and multiply. Please don't talk. Then what happens? One of your t's cancels. So we're left with t squared over -2. What do we do now? Yep. Every time you take your derivative, you want to direct substitute. So we're going to try it. If it gives you the indeterminate form, take that derivative again. There's nowhere on the sheet that you had to take a second derivative. Okay, so if you did that, you didn't have to. Plug it in, we get 0 squared over -2, which is 0. Don't forget that you took out the 4 in the beginning. And the only reason that I write that is just in case it comes out to be like 1 or something else. So your answer to this one should be A. Any questions? Next one. You're going to go ahead and take the derivative. What's the derivative of 2t? The derivative of t plus 1, ln t plus 1. We don't divide by fractions. We flip and multiply. Make sure that you're distributing. So we get 2t plus 2. Once we take the derivative, we direct substitute. 2 times 0 plus 2, and I get?
Almost had it.
You're real close.
She was yelling at me, telling me it was 4 yesterday. She was like, "You're wrong."
Is everybody good? All right. What do I do on this one? Ignore the 4 for a little bit. What about secant? What can I do to it? The reason we're going to do that, change it to, I told you, I'm going to change it to X just because it's easier to look at. Because we can change tangent into what? Which gives us a common denominator. So we can just write that together. 1 minus sine X over cosine X. Once we get it simplified, we're going to take the derivative. What is the derivative of 1 minus sine X? Negative cosine X. Derivative of cosine X, which is the same thing as cosine X over sine X. Once you take the derivative, you direct substitute. So cosine 0 over sine 0. I'm sorry, because it gives you, sorry, y'all, 0 over 1. I was a step ahead. I apologize. And then we get 0. Don't forget that we had a lot of you did. Don't forget you had the 4. Just leave it. Just leave it. Look. But if I see you with it, put them on your, get them out of the, just don't even have them near you. Come on, guys. Don't forget the 4. When I multiply by 4, I still get 0. Very good. Good job, Tammy. Hannah's going home now. Hannah's going home now.
What grade is she born?
Is it about Snapchat?
I heard about that yesterday, but
Number 4. Number 4. Take the derivative of ln r, which is, take the derivative of r, which is 1. This is the same thing as just 1 over r. When we have infinity, what did I tell you we needed to do? Graph it. When we graph, you should already know this. 1 over x. As we go to infinity, your graph gets closer and closer to 0. So very good. Next one. So these are the ones, like the reason I keep screwing it up is I forget that I do ln, and then I got to remember to go back and write ln y equals whatever the limit is. So don't forget to do that. That's the mistake that I'm making. I think I did 40 different times in 40 different ways to get the same exact answer every time, and forget the fact that I needed to write ln y equals that number and then e it. Okay, so don't forget that. So on 5, what do we need to do? We're going to ln, but we're going to do what first? Yeah, ignore that 4. So I'm going to write tan x. I'm going to just go do it all at the same time. ln sin x. The reason we ln sin x is so that we can bring that power of tan down because there's a variable in there. We're going to rewrite it and we're going to put tan on the bottom. It would be 1 over tan, which is what? Guys, come on. We just had it. So that should make you think about, hey, I should probably check my phone and see if it's turned off or down, or I don't care, but fix it, please. Once we simplify it, what do we do? What's the derivative of sin x? So ln sin x is cosine x over sin x. Derivative of cotan. Negative cosecant squared x. What is cosecant squared? We can change this to -1 over sine squared x. And instead of dividing by fractions, we have cosine x over sine x times sine squared x over -1. What happens? One of your sines will cancel out. You have cosine x, a negative cosine x because of this -1 times sine x. Once you take the derivative, what do you do? Gives you 0 times 1 or 0. This is the part, like, I see that answer is on there, but that is not the answer. Does everybody understand that? Don't forget that we ln'd it in the beginning. So we have to write ln y equals 0. We're going to e both sides. What is e to the 0? 1. What did we do in the very beginning? Took out a 4. So 1 times 4 is 4. So that little bitty last step is the one that I keep screwing up. What? No, 6 was. You'll see why. What do you think? Yeah. So. Everybody good? What?
How did you go from cosine to negative cosine?
The derivative of cotan. Yeah. So use your cheat sheet. Of the top and then the derivative of the bottom. Yep. No. When we put this on the bottom, it would have been, when we move it to the bottom, it's 1 over tan. When we have to put it on the bottom.
Where does the cosine x over sine x?
Put it right here. What's your derivative of this? Remember, it's u prime over u.
Oh, okay.
So sine is cosine and then over your sine. It's all right. Sometimes I look at it and forget the LN's there too. Hold on. Where we had to put the tangent on the bottom. So remember how it would be like tangent to the -1, but we can write it as a fraction. So 1 over tan, which is cotan. So here's what I'm saying, just so you can see it. We had tan x, ln, what I have, sin x. So we want to put tangent on the bottom. So it'd be tan x to the -1. Remember, another way we write that is 1 over tan instead of having the -1 power. And then 1 over tan is cotan. Otherwise, to find the derivative of this, I mean, you're still going to do it. You can do the -1 tan to the negative, whatever. That's fine. It's all going to work out that way if you want to do it that way. But you still have to take the derivative of tan. So it's going to end up being the same, but it's a lot more work. It's a lot more work. All right. All right. So this one, what do we do? All right. So I did this, like I said, I did this 40 different ways. So I'm going to listen to you guys and I'm going to do it whatever way that you say. So I might have a different way than what you had, because like I said, I did it 14 different ways and then, oh, it's just ridiculous. So the sign is going to come to the front. I'm going to rewrite it as X instead of R. ln tan X. What do I have to do now? So I did sine to the -1, that like the last time I did, but you can do it any way that you want to. You said what? Cosecant X. From here, we do the derivative. What's the derivative? Remember, it's u prime over u. So what's the derivative of tan? Secant squared x over tan x over, what's your derivative? Cosecant. Reese, where you at with the cheat sheet? Negative cosecant x cotan x. This is over 1. This is going to get crazy. You ready? I didn't like it this way. Actually, it's a lot harder than what I did the 40th time I did this. It's okay.
When I got a fraction, and then like there's some crazy things going on.
It's all good. Okay, so we're going to flip and multiply. Flip and multiply. What is 1 over 10? So I can change this to cotan x, secant squared x. Is that right, good? Over negative cosecant x, cotan x. What happens? Okay. What is cosecant? Say it again. So we can change, see how they're on the top and the bottom? Does everybody understand that? So since this one's on the bottom, I can change it to the other one and put it on the top. So whatever your 1 over, so cosecant is 1 over sine, flip and multiply, it can go to the top. Does everybody understand that? So it looks a little easier. Why? Because I can put that in my calculator easier and it's not going to cause an error. Does everybody understand that? So cosecant turns into sine x. What does secant squared turn into? Cosine squared x, right? Don't forget your negative. It doesn't matter if it goes on the top or the bottom. So now I can put in my 0. It's not really going to matter because sine of 0 is 0. Cosine of 0 is 1. Doesn't matter where you put your negative, still going to give you 0. So then I would get there and forget. So I'm getting the wrong answer every time. That I have to do ln y equals 0 because I ln'd in the very beginning. E both sides. And I get y equals 1. And then what do I need to remember? Multiply by the 3 I ignored in the beginning. So your answer is 3. That's the worst one. No, that one is the hands down the worst one because there's so many cosecant, secant, and cotan. Everything else is, I mean, I came in this morning and did this while I was doing the faculty meeting, and it took like 3 seconds to do. So it's good.
If you're getting to the end of like the derivative, and you still got like secant or cosecant.
I would try to write it as sine and cosine, so it doesn't give you an error in your
Okay,
calculator.
like toward like at the end.
Yes,
Okay.
yes.
And
right.
so, like
Sorry.
if it's cosecant on the bottom, you switch that one to a top for like sine and then the other one. Okay.
Yep. All right, what about this one? How can I'm gonna ignore the 5. Shh. There's a bunch of these. There's a bunch of these on this one. I'm not saying there will be a bunch tomorrow, but there possibly will be. Like I said, whatever regenerates happens. All right, so what do I do on this? First thing, ignore the 5. What is secant? And again, I'm gonna change it to an X. Minus tangent is? Why did I rewrite tangent? Because it's an easy function. So I had a common denominator. So my simplified version is 1 over sine x, 1 minus sine x over cosine x. Now it's easier to take the derivative. Derivative of 1 minus sine x, negative cosine x. Derivative of cosine, negative sine x. From here, it's a positive, and we're going to plug in pi over 2. We get 0 over 1, or just 0, and then what do I have to remember? Times 5. It's not going to change the answer. So it's 0. Guess what's going to happen on the next one? Same thing. Same thing. All right. Cosecant. 1 over sine x. What about cotan? Cosine over sine.
Are all these things on the sheet also?
No.
I didn't.
So remember, cotan is 1 over tan. It goes with tan. The way I remember these, cosecant goes with sine. They do the opposite letters. And then secant goes with cosine. It's always opposite letters.
One over.
Yeah. Oh, yeah. All right. So your common denominator was sine. So 1 minus cosine x over sine x. Now we can take the derivative. What's the derivative of 1 minus cosine x? Positive sine x. Derivative of sine x. Then we're going to plug in 0. What is sine of 0? Cosine of 0 is 1, which still gives you 0. I didn't take anything out, so I'm finished.
If they're like this, you can almost know. Zero or the number that.
Yeah, if you have to you have to watch them. All right, ready?
Wait, so ln is the view from the views. That's when you do.
You need to do the work, though. You need to do the work. All right, this one. Yeah, this one you have to ln. Why? A t in the power. So ignore the 2. We're going to bring that power down.
So Ellen just brings it.
Yep. And then you want to put the sign on the bottom. Because we want to divide so that we can do the derivative of the top and the derivative of the bottom. So we want to move that front number to the bottom so that we have a fraction to do L'Hopital's rule. That's the whole point. Okay. So how do I put it on the, sorry.
So you just put in. Okay, I think that-
You sure?
Not sure. I'll get it.
Okay. So we're going to change it. And that sign is going to go on the bottom, and we can rewrite it with a -1 power. We can rewrite it like this. We can even write it as what? I should have changed it to X. Keep going, derivative. Secant squared over tan. Okay. It went away for the first part. So we just made it go away when we took the derivative. We have not, like literally what we should do is carry this throughout the whole problem where you ln both sides. So we should have set it equal to y, but I always wait for the very end, which screws me over. So maybe you shouldn't wait to the very end. Does everybody understand that? All day or all morning this morning. Okay, sounds good to me. All right, what is secant squared? Secant is just cosine? 1 over cosine, that's what I needed. 1 over cosine squared t. What is tan? It's sine over cosine, but instead of dividing by a fraction, we flip and multiply. Does everybody see that? We're going to hold on to this bottom for just a minute. I'm going to fix it, but give me some time. What happens on the top? Cosine cancels out. We're left with 1 over cosine t sine t. What is cosecant? 1 over sine, right? And cotan is, but tan would be so it's cosine over sine, right? Good. Why is it like that?
Because it's 1 over.
Mhm. All right, so on the bottom, and I'm not going to use a bunch of room over here. It's a really quick problem. This whole bottom would be cosine over sine squared t, whatever, cosine over sine squared t. But instead of dividing by a fraction, so we're going to have sine squared t over cosine t. What happens? One of your sines cancel out. So we get sine t over cosine squared t. And we can direct substitute. We're going to direct substitute 0. Sine 0 is 0. Cosine 0 is, and we're going to square that. It's not going to matter because you still get what? Last step. Multiply that 2, you're still going to give you 0.
We're gonna do that.
God bless you. I told you every time.
Do you do the 2 first or then you do the 2?
No, you do the 2 last. You do the 2 very last. Very last, because I told you that's what I keep messing up. So I feel like y'all will mess that up tomorrow too. And I'm sorry. Yep. I do it every time. ln both sides, which gives you what? And then multiply by 2, which gives you 2. I apologize, y'all. I'm telling you, the next time we do this problem with the ln, I'm probably going to forget it at the end as well. So if I were taking this test, I would probably forget that. I would get these wrong. Not because I don't know how to do it, because I forget to do it. It happens. All right, this one. Change this to what? X to the 1/2 minus 1 over X minus 1. Derivative of the top. Derivative of the bottom. So this is just 1 over 2 times the square root of X. Direct substitute, we get 1 over 2 times the square root of 1, which is 1/2. Yeah, they're that easy. That's why I said I'm not gonna take up a bunch of room. I knew it would be really quick.
I know, I make it so hard in my head that I just forget that all you do is take the derivative.
These, you know what the answer is. You know what the answer is gonna be. So these, you're gonna get the answer right, but try the work, is what I'm telling you. What are you benefiting from if you're doing all this work right here? So that you can learn derivatives and you can learn how to simplify trig functions, right? Because how much did we do that? A lot, right? So we want to make sure that we're back in that mindset. So we're manipulating all those trig functions. We're learning the derivatives of the trig functions so that when we get like that multiple choice diagnostic real soon Monday, then it's it. That's it. Why are you worried?
This is our last thing. This has been so much easier to like simplify than when we first.
Right. So now you've learned it, you're practicing it more. It's the same concept that we're going to do with this exam review. Like you're going to take the diagnostic and I want you to do it like for real. I need you to do it. Okay. Y'all understand that, but I am putting you on a time limit. Why? Now we got to learn how to take this test, right? So whatever time limit they give us, that is what I'm going to give you. So if we start, for some reason, we talk to 1/4 and we start at 1/4, I will still give you the full time that you're supposed to get. Does that make sense? But then it's drop dead. So you need to learn to take this test. The first part is multiple choice. So all you're going to be working on probably for about a class period and a half is multiple choice. Then it's like 30 minutes a question. Like, I mean, it's grueling time-wise, but it's enough time that you can finish. So you shouldn't be pushed for time. Does everybody understand that? You should not be pushed for time. If you're pushed for time, it's because you sat there and looked at it, looked at it, looked at it, looked at it. Move on, go to a different one.
I'm gonna be so embarrassed if I do that.
Why? What's the point of me giving it to you? What? This is different. This one is different. This one is different. This is, I'm going to give it to you and I need to know what you know. It's for me. It's not for you. It is for you, but it's not to hurt you. That's why I said you need to try on it. You need to actually work. So you know what you need to work on and I know what you need to work on. Does that make sense? Then, guys, after we do the multiple choice, you're going to get free response. We really haven't worked any free response at all. Why? Because you need to know how to do the math before you apply the math. So I'm hoping that this will help a lot because this is not how it's been taught. Everybody understand that? But this is how I taught stats and I have pretty decent scores with stats doing that. I teach you the math and then we work on test taking. So that's what we're going to do. So don't stress out like it's going to kill your grade or you're going to, it is just knowledge for the two. It's data. Okay. That's all it is. Sammy, you barely get that. I'm just kidding. I'm just kidding. I'm just kidding.
Wait, so is it gonna be just like a not graded at all?
Oh, it's going to be graded.
Yeah, but like
It's going to be graded. That's what I can tell you. I don't know how, I don't know what I'm going to use it as or whatever. I need to know what you know. But you need to try. Yes, it is going to be a grade in the grade book. It is going to be a grade in the grade book. Do you want it to hurt you or do you want it to help you? Try. I better not get done in 5 minutes. Somebody done circle some answers. I'm not playing that game with you. You have spent the entire year working on calculus and busting your butt in here for the most part. To go to a test for 3 hours and do nothing, you got nothing else to do. Do you understand what I'm saying? Why would you not just try? It makes zero sense to me. What is the worst thing that'll happen?
Make it two.
What's the best thing that'll happen?
Make it five.
Do you understand if you make, for certain courses, it's fours and, or like for certain colleges, it's fours and fives. For a lot of colleges, it's 3 4s and 5s. I cannot explain this to you anymore. Some of you are going to get lots of scholarships and that's great. But my parents did not have the opportunity. Like I got a little bit of a scholarship, but I went to a private school. So my tuition was ridiculously high, still paying student loans. Everybody understand that? I am 39, still paying student loans.
I just student loans work, you just pay every month. Like,
Yeah, and they're low interest, so they last a long time. So, and I've taken courses since then, like a lateral entry, took courses. So once you reapply to college, your loans are deferred. So like if you guys get loans and you're an undergrad, but you continue through grad school, then you don't pay a loan till you're done. Does that make sense? So then when I went back and got my master's degree, the loan stopped again. Now, because of COVID, they have a whole deferment process through the government. So I haven't paid a loan in forever. Does that make sense? So with all the deferments and everything else, I'm still paying them. They are not near what they were. They are not near what they were. But for me to go, I had to get loans. I had to, because I wasn't one of the ones that, and I do not mean this in a bad way. If your parents are divorced, you get a better like help on your tuition. If one of your parents doesn't work, you get more help on your tuition. If your parents are married and they both work, the chances of you getting any money are slim to none. Slim to none. And that's okay. I'm not complaining about that, but I'm just letting you know that that's how it works. So what this does is 2 things. All these AP courses that you guys are taking transfer into your college, which means you could go to college less time before you get to your grad school if you're going to grad school. Does everybody understand that? So I came in with a couple credits. So I was technically a mid-year freshman when I came in. Does that make sense? So I could have graduated early, which would have saved me some money. It's saving money. So let me break this down for you. When I went to school a million years ago, and then I was taking courses in the summer for my teaching degree, here's the difference. Pfeiffer was $300 a semester hour. Most of your courses are 3 semester hours. Okay, 300. So $900, $1,000 to take 1 class. Then you get to, no, wait a minute, maybe I lied to you. No, I think I'm good. A state school is about 1/3 of that. So 100, 150, half to 1/3. But still, that's 300 to 500, 600. I mean, it's a lot if y'all think about it. That's 1 class. That's 1 class. Now, if you go to community college, when I went, it was like $50, so like $150 for the whole course. That's not terrible to me. So that's why I tell y'all, like if you, here's my word of advice. You get into college, you get a math class that you're not okay with, it's not good. Come home in the summer and take it at the community college.
Well, I've already been more.
Take it to the community college. Right. It transfers in. It transfers in. Does everybody understand that? If it's not part of your major, I mean, try to take it in the summer during community college. And it sucks to take summer classes, but it's really not that bad. It's really not. Does everybody understand that? So why do we want to pass this AP exam? So that's 1 less course we got to buy in college.
If you take the class, you take it online, or you have to go to college.
No, you can take it as long as it doesn't have a lab. Like if it has a lab and you have to do something in person.
Because I'm 100% taking chemistry at community college.
If it is 100% online, now you have to look. If it's hybrid, you might have to go in. But it might be that your coursework is there, but you have to come into your labs. So I don't know. Like when all COVID hit, like everything was online. So I guess they were doing labs online, like computer programs or something. But I don't know. You'll be fine. All right, let's keep going. We need to get finished. Sorry, Caitlin. All right, what do we do? We got what? 2, and then we're going to LN. Don't forget to do E at the end. So we're going to put the 1/x in the front, ln x. The good thing is that this is already a fraction. So when I multiply these together, the x is just going to go to the bottom. So you don't have to flip it or you don't have to do anything. Take the derivative of ln x. 1 over x. The derivative of x is, which gives you 1 over x. Anytime we have infinity, we've already graphed this one time. It looks like this. So it goes to 0. Oh my God, I told you every time.
Yeah, I'm about to say I got 2. We're confused.
Ugh. Ln y equals 0. And I told you before the whole problem that I was going to do it. I'll try to remind you before. When you E0, you get 1. We pulled out the 2, which gives you 2 every time this morning that I did this problem.
It's so nice to actually understand what's going on.
Me too. I like.
Just the last 3
I'm just
sections.
confused about all like
Yeah.
the little things, like I get. Like,
That's what I've told you. Yeah, yeah.
It's gonna be at that.
but like last unit, like I didn't like this.
No, the last unit was so, that was, okay, it took like 3 class periods.
We gotta go.
Yeah.
Yeah, but that's because we had delays. All right, take out your 3 ln(t). What's your derivative of ln(t)? Derivative of t minus 1.
If you want to keep it
1.
free, could you just divide it by?
No, just take it out. Just take it out every single time. Which gives you 1 over t. Our limit is 1. When I direct substitute, I get 1 over 1 or 1. What did I forget? Took out the 3. I didn't know. That stuff, which is 3.
This one I accidentally left the 3 in, but it's.
All right, ignore the 2. We have ln x. You guys said yesterday you would rather put the x on the bottom and making it a -2 than a 1 over x squared, which is perfectly fine. Take the derivative. Ln x is the derivative of x to the -2. Okay, remember that becomes -2 over x cubed. So instead of dividing, flip and multiply. What happens? So we get x squared over -2. Direct substitute, we get 0 over -2 or 0. Don't forget to multiply by that 2. I almost circled 2. Okay, so this is a fraction. Instead of dividing the fraction, we flip and multiply. So we flip that x to the third over -2. The -2 is still hanging out there. Yes. All right, 14. What do I do on 14? You don't even have to. Ignore it till the end. Remember, because we'll take it out anyway. So we just go ahead and take the derivative. What's the derivative of this e to the r minus e to the -r? Plus e to the -r. Good.
Okay.
What's the derivative of -r?
Oh,
-1 times negative is positive.
do we still leave the 5 alone?
Hang it till the end. Yep. On the bottom, cosine r, guys. Once we take the derivative, direct substitute. So e to the 0 plus e to the, and you know it's not negative or positive 0, but for all purposes here, cosine 0. E to the 0 is plus e to the 0 is over cosine 0 is 1 plus 1 is over 1 is. Last step, multiply by the 5.
So you don't have to do ln on that one, even if it's
Because it's east. Yeah. The next one is 16. That will do that.
Okay, so that's what I got a question.
Okay. All right, this one, same thing as that last one. We have w minus 4, but we're going to change it into w to the 1/2 minus 2. Derivative of W. Derivative of W to the 1/2. Yeah, no, you're fine. If you change it to X, perfectly fine. Don't stress out about that. All right, which changes it into 1/2 to the square root of W. We don't divide fractions. We do what? So I'm going to take this one and multiply it by the flip, which just gives us 2 square root W. Is everybody okay with that? What is W? What's the square root of 4? Times 2 is 4. All right, don't even forget on these next 2 problems. Right. I have a variable in the power, so I need to ln. So I bring the variable power down, ln 2s plus 1. Good thing is it's already a fraction. So we just write the s on the bottom. Derivative of 2s plus 1. And then what's the derivative of s1? So it doesn't matter. We're going to direct substitute at this point. We get 2/1 or 2. Don't be dumb like me. I took the ln. So I need to set it to lny. And then how do I solve? And if you look, y equals e to the second. We didn't take anything out, so there's no multiply by anything. Your final answer is e to the second. Same thing on the next one. How do I get the 2r down? ln. So I'm going to have 2r ln r. How do I fix it so that we have it on the bottom? Yeah, I'll let the r out. I mean, I'll let this do that. I don't know. We're going to try it. I'm just saying in my work, I left it out. I don't think it's going to change the answer at all. All right. So how do I fix it? To r to the -1. Derivative of ln r. 1/r. Derivative of 2r to the -1. We flip and multiply. Remember, this is -2/r². So we're going to flip it and multiply. What happened? Which just gives us r/-2. Like I said, it's not going to change it at all. Right. What is r? So we get 0, but what do I need to remember? It's ln y equals 0. E both sides. We didn't take anything out. So we just have 1.
It doesn't matter.
This one?
Yeah.
No. Yes and no. Because if you don't cancel out the r, you come up with an indeterminate form. So just be careful. On this one, it's not going to matter, but another problem it could. Okay. All right, 18. What do I do? And then t to the -2 on the bottom. Derivative of ln t. Derivative of t to the -2. So again, this turns into -2/t cubed. Instead of dividing, we flip and multiply. This is the same as the last problem, except for we didn't have to ln it. Take out a t, so it changes to t squared. You direct substitute, you get 0 over -2 or 0. Last step is I need to multiply by that 5. Still not going to change anything. So if you forget that step, that's fine. Don't forget the ln step. And then ln when there's a variable in the power. Is everybody good? All right, 19. Yep. ln t over t to the -1. Ignore your 2. Derivative of ln t. Derivative of t to the -1. Which is going to be -1 over t squared. So we're going to flip and multiply. T squared over -1. 1t will cancel out, which gives you -t. Plug in 0, and then you're done with the problem. Multiply by 2, doesn't matter. No. Remember, the only ones that we have to worry about messing up in the end are the ones that have the variable in the power. That we make the ln, not that start with ln.
What's different about the one that's right above it?
We didn't pull out the 2 because it was with the power. It wasn't 2r to the 2r to begin with. Now, if I had 2 right here to begin with, pull it out and then do it.
Okay. Where it, like you put the L and T on top.
Mhm.
That's because there's like the hot, like why do we put the L and T on top and not the just T like we do? Like you know what I'm saying? Like every time we do like,
Why do we keep this ln t on top?
yeah.
Because what is the derivative of ln t in parentheses to the -1?
Wait, what?
Exactly.
I'm confused.
We have to make it a fraction.
Yeah.
Okay, so which one is easier to put in the bottom, the ln t or this t?
The T.
You see what I'm saying?
Okay.
It'll still work. You can do either one of them. Yeah, it would work, but
Okay, because I always noticed that we always kept the L and T.
yeah, because it's much easier to do that.
Okay,
It's
I
much
just
easier.
wanted to know why. So my
Yep.
brain thinks-
That's all right. All right, what do I do on 20? Secant is 1 over cosine. I'm gonna change it to x. Tangent is sine over cosine. We did that so that we could get a common denominator, and we're gonna squish them together. Take the derivative. Good. And then we're gonna plug in pi over 2. Negative over negative makes a positive, so I don't have any negatives anymore. Cosine pi over 2 is 0, sine pi over 2 is 1, which gives us 0.